Welcome back to Afredi YouTube channel. If you are yet to subscribe, turn on the notification bell so that you'll be notified whenever we dish out a new video. So today we are going to look into dimension in physics. Dimension in physics. What are dimensions in physics? Let's pen it down. Dimension are the powers to which fundamental units or quantities are raised to represent a given physical quantity. So in physics, dimensions are the powers to which fundamental units or quantities are raised to represent a given physical quantity. In physics, dimension understands three languages. It understands three languages. Number one, mass. Number two, length. Number three, time. Mass, M. Length, L. Time, T. So in bracket you have M, L, T. So in physics, dimension understands three major languages. Number one is mass. Number two is length. Number three is time. So if you know these three, you can be able to solve dimension very perfectly. So let's begin. Let's begin with the examples. For example, you may be asked to find what is the dimension for velocity. What is the dimension for velocity? First of all, you have to note the formula for velocity. What is the dimension question mark? First of all, if you want to solve dimension for velocity, you have to note or know the formula for solving velocity. But for our physics, velocity is displacement all over time. Velocity is displacement all over time. Now, displacement is measured in what? Meter. Time is measured in what? Seconds. Now, the easiest way to find dimension for velocity is to convert this meter and seconds into the language that dimension understands, which are mass, length, and time. So, if you have meter here, it means that this meter will be your L. And if you have seconds here, it means that this seconds measures what? Time. Meter measures length, while seconds measure time. So dimension for velocity will now be Lt minus 1. Why? Because you have the power of this t is 1. When it comes out, it becomes minus 1. So dimension of velocity is lt minus 1. Let's take another question. They may ask you the second question now. What is the dimension for acceleration? So what is the dimension for acceleration? First of all, you have to know what acceleration is. The formula: acceleration is change in velocity over time. So change in velocity means the final velocity minus initial velocity over what? Time. Now, if the final velocity here is 0, it means that you have, if the initial velocity here is 0, it means that you have the final velocity minus 0 over what? Time. Then you have v minus 0 is v all over what? Time. Now, velocity is measured in what? Velocity is measured in meter per second. Meter per seconds. Time is measured in what? Seconds. So you have to convert, this is meter, this is seconds, this is seconds. You have to convert this meter into the language of dimension so that you have, so that meter will be your what? L. Seconds measure what? Time. Seconds measure what? Time again. So you have that your dimension will now be L t minus 1 minus 1. So you have dimension to be LT minus 2. Because minus 1 is minus 2. Now this gives you dimension for what? Acceleration. Now let's take another question. What Now let's take this question. Question 3. The dimension of universal gravitational constant is option A. You have m raised to power minus 1, L raised to power 3, t minus 2. B, m L3 t minus t2 raised to power 2. C, m L raised to power 3, and D, m L t minus 2. So this is the question. The dimension of universal gravitational constant is this. So let's begin. Let's solve. If possible, you can pause the video and try the question. So let's begin. In solving dimension for universal gravitational constant, you have to first of all note the formula. Force is directly proportional to the product of two masses. divided by r raised to power 2. Now, you have to remove this sign of what? Proportionality. Here you introduce your constant g. So you have f force is equal to g m raised to power 2 divided by r raised to power 2, because m times m times m is m raised to power 2. So this m is mass, which is mass 1. This m2 is mass 2. So mass 1 times mass 2 will give you m raised to power 2. So look at what we are looking for. We are looking for this g here, which is universal gravitational constant. So in finding g, you have to make g the subject of the formula. So you cross multiply, you have g m raised to power 2 is equal to f r squared. Then you divide both sides by m raised to power 2. So you have g to be what? F raised to power what? F r raised to power 2 divided by m raised to power what? 2. So this is the formula that is going to lead us in getting dimension for universal gravitational constant g. Then after that, we begin our solving. Now, if g is equal to f r raised to power 2 over m raised to power 2. Now, force is what? Force is mass times acceleration. This r that you are seeing here represents your distance. So in bracket here, r is equal to distance, which is measured in meter. In meter m. So it means that this r here is your distance, which is measured in meter. I use d square to represent the r there. So m is your mass. After that, this is mass. Now, what is the SI unit of acceleration? You ask yourself, what is the SI unit of acceleration? Remember, acceleration is meter per second squared. That means from our derived quantity, which is pointing at derived unit. So if acceleration is this, put the unit for acceleration under acceleration, so that you have meter per second squared times d is distance, and distance is measured in meter. So you put meter there, meter squared, divided by, this is mass. This big M is mass, not meter. You put it down, mass squared. Then after that, you have to convert into the language that dimension understands. So dimension understands mass. Dimension understands meter in form of length. Dimension understands seconds in form of time. It understands meter in form of length. So this is mass. It understands mass. After that, mass here, we can one mass here. There is mass. There is two masses here. So you have G to be mass times L squared times T raised to power minus 2 divided by, you split these masses here, mass times mass, because mass times mass is m raised to power 2, which is mass raised to power 2. So one mass here, we cancel one mass here. So one up, we cancel one down. So you have L times L square is what? Look up. L times L square is, the power of this L here is 1. So you have L here, you have L, you pick 1, L raised to power 1 plus 2. So giving you L raised to power what? 3. So you have L times L square is L raised to power what? 3 times T minus 2. Divided by M. So after that, you bring this M up, so that you have M raised to power minus 1, L 3, T minus 2. Therefore, dimension for universal gravitational constant G is equal to M minus 1, L raised to power 3, T minus 2. That is option, that will be our option A. That will be our option A. So option A is the correct answer. So let's solve another one. Let's solve another question. This question says, question 3, 4 says the dimension of electromotive force option A, you have M L squared T minus 3 I raised to power 1. Option B, you have M L squared T minus 3 I raised to power 2. Option C, you have M squared L T minus 2 I minus 1. So let's begin. You can pause the question. You can pause the question and try. So let's solve. What's the dimension of electromotive force? Now, the problem that you have here is if you cannot be able to know the formula used in solving electromotive force. But remember that work is equal to EQ. Work is equal to EQ. E is the electromotive force, Q is the quantity of electricity, W is the work done. So let me write it down. This is work done. E represents electromotive force. Q is quantity of electricity. So if you have that W is equal to EQ, you make E the subject of the formula there. You are going to have that E will be equal to work over Q. Now, what is work? Bring that work. Work is force times distance. And what is Q, which is the quantity of electricity? Q is current times time. That means this Q here is IT. So after that, force is what? Force is what? Force is mass times acceleration times distance divided by I times time. So this is mass. You have mass times, what is the unit for acceleration? Acceleration is A equal to meter per second squared. So you have meter per second squared times, what is the unit for distance? Distance is measured in meter. Current, you have your current here, times time. Time is what? Seconds. Remember, dimension understands mass, length, and time. Dimension understands mass, length, and time. So after that, you have to convert the unit into the language that dimension understands. So you have, this is mass, leave it there. Dimension understands mass. Remember, what we are focusing at is MLT. So multiply by, this is meter, measures your length. This is seconds, measures your time. This is meter, measures your what? L. Divided by, this is your current, times, this is your what? Seconds, which measures your time. Now after that, L times L, you have your mass, times L divided by times T minus 2. It's like we are collecting the light ends. L times L here, then times T raised to power minus 2. Then divided by I times T. So L times L is what? So you have that L times L is L raised to power 2 times T minus 2 divided by I times T. You have to bring these two up. Bring I up, it becomes I raised to power minus 1. You bring this T up, it becomes T raised to power minus 1. Then you are going to have mass L raised to power 2, then T minus 2. When this T comes up, it becomes minus 1 times I raised to power minus 1, because this I comes up, this T comes up, it becomes minus 1. That T raised to power minus 1. Then we are going to have M L raised to power what? 2 T raised to power minus 3 I raised to power minus 1. This is dimension for electromotive force. And this is option A. Option A from our equation is correct. So this is all about dimension. You can stay solve more. You can stay find. You can stay solve more. You try this one at home. Find the dimension of the following. What find the dimension of the following physical quantities. Number A, work. B, density. C, volume. D, momentum. E, pressure. So drop your answer on our comment section. We'll attend to you. Thank you so much.